Okay, we are going to be looking today at solving one-step equations. Now, in order to do that, we need to start off with just what is an equation? An equation is simply a math sentence with an equal sign. An equation states that the two sides are equal. So what that means is whatever is in this box on the left-hand side is equal to whatever is on the right-hand side. They do not have to look the same. Now, for me, I like to kind of think of it like this. I kind of like to think of it like a teeter-totter. So you've got a person on one side, you have a person on the other. Now, when you are teetering, if both of those people are the exact same weight, then that teeter-totter is going to stay exactly equal. It's going to stay exactly flat. But if I were to come along and add a second person to this side, then that teeter-totter is now going to take, and it is simply going to start going like this. So you have the two people on this side, and you have the one person over here. Well, to undo that, to get it to stay equal, we would have to add the exact same thing to the other side. Or the other option is simply to take away that part. So when you look at that, that's how I like to think of equations is we want to keep everything equal. So we want to keep our teeter-totter exactly level, okay? Now, when we start looking at steps to do this, one of the steps I always like to start off with is simplifying when possible. What does that mean? Well, we try to collect like terms. We might have to do the distributive property, things of that sort. We will not be doing step one very much at all until we get to a little bit larger equations. Then what I like to do is I like to draw an upside down T through the equal sign. This will separate the equation into the two sides, the left side and the right side. This is an organizational tool. So what it would look like is if we had a problem, let's say I had x plus 5 equals 7, what we would simply do is we draw that upside down T, separate it, and then that gives me a nice place to do some work, and it's easy to follow. It helps me to work vertically. Then what we're going to do is we are going to isolate the variable by using these things called inverse operations to solve the equation. First question, what does it mean to isolate? Well, that means we want the variable to be alone. We want it on one side of the equation completely by itself. Now, kind of a way to think of inverse operations is they undo each other. So what undoes? Well, if we stop and think, if my problem has addition in it, what will undo it? Well, it would be subtraction. And if my problem has subtraction, addition will undo it. Likewise, if my problem has multiplication, division would undo it. And if my problem has division, multiplication will undo it. So those would be called inverse operations. They undo each other. So that's what we're going to use. And we're going to get rid of the things by the variable, the values by the variable. We're going to get those away. And we're going to be left with the variable completely by itself on a side. Now, once we've done step 3 correctly, we should now have the value of x, the answer. And once we have the answer, we can always check your answer by plugging your value back into the original equation and then using that order of operation skills, plug it in and work it out to make sure that that answer is correct. So let's give it a shot. Here we go. So on this first problem, we have y plus 8 equals 2. So what I'm going to do is there's no simplifying, so I'm going to draw my upside down T. I look at y. I need to get rid of this plus 8. Well, how do I do that? I would subtract 8 from both sides. So now that cancels, and that would leave me with y equals 2 minus 8. Well, if you think about that, you have $2, you take away $8, or you buy something for $8, that's going to leave you with a negative 6. Now, how do you check it? Well, you would come over here and you would evaluate it. So you would plug this back in, and it would simply say negative 6 plus 8, and you're asking this question, do you equal 2? Well, negative 6 plus 8, you do that problem there, and it is 2. So we know that we have the right answer. Okay, let's move over to number 2. So on number 2, we start off, we look, there's nothing we can simplify. So what am I doing to x? Well, I'm subtracting 5. So to undo that, I'm going to add 5 to both sides. That gets rid of that, and x then would equal 3 plus 5, which is 8. Now, if you wanted to check it, you would simply plug it back in, and it would say 8 minus 5, do you equal 3? Well, 8 minus 5 is 3, so that tells me I'm doing that correctly. Okay? Number 3 here, when we look at number 3, we'd start off, nothing we can simplify. So this one says 6 times x. We need to get rid of the 6. So since I'm multiplying, I'm going to divide. So when I divide, I would be left with x equals 5. Then at that point, to check it, we'd go 6 times 5. And indeed, that does equal 30, so that we know we did that one correct also. Number 4 here, we start in and we say, okay, what am I doing to w? W is being divided by 3. So to undo that, we multiply by 3 to both sides. And that's going to leave me with negative 5 times 3, which is negative 15. To check it is very similar to all the other ones. So you're going to go negative 15 divided by 3. And does that equal negative 5? And the answer is yes, it does. So we know that we did those 4 problems correct. Let's try a couple more. Now you're going to notice a couple different things. One, I'm going to put some fractions in here, and also you're going to notice the variables are not always on the left-hand side. They don't have to be, so we have to be prepared for that either way. So here on number 5, we're going to start in and we say, okay, what am I doing to w? Well, if I look here, I have 9 plus w. Now remember, that plus sign that we have really goes with the w. So what we do is we look at the 9. The 9 is a positive number. So to get that to disappear or to go away, we want to get rid of it. We want it to go to 0, so we have just w. We're going to subtract 9. So that would leave me with w equals negative 12 minus 9. That's going to give me negative 21. If you want to think money-wise, you are buying something for $12, you're buying something for 9 more, that's going to leave you with buying something for 21. Okay, over here, we do this problem the same way, except for it's a fraction. So we start off, what am I doing to x? Well, I'm adding a negative 1/3. Now remember, the plus sign goes to the x. So we have to look in front of the number. It's a negative 1/3, so I am going to add 1/3 to both sides. So that would cancel that, and I would get, well, now we have to find a common denominator. And in this case, it would be a 12. So I start in and I say, okay, 4 times 3 is 12, so 3 times 3 is 9. 3 times 4 is 12, so 4 times 1. I would add that together, and I would get 13 twelfths. Now, if you wanted to, you could write that as a mixed number, but you do not have to. You do have to simplify, but 13 and 12 have nothing in common. So therefore, that is a justified answer. That is a correct answer there. Okay, let's try a number 7 here. So on number 7, I'm taking 1.2 and multiplying it to x. So to undo that, I'm going to divide by 1.2. So we start in and we say x is equal to, well, how many times does 1.2 go into 4.8? Well, that would be a negative 4 times. Okay, and that would get us that answer. Okay, over here, now this one is a little different. So when we look, we are taking negative 3/4 times x. Well, to undo that, we are going to divide by negative 3/4. Now, here's the deal though. I don't want to divide by a fraction, because when we divide by a fraction, remember, we multiply by the reciprocal. Remember, we flip that. So what I'm going to do is I'm going to save myself a little step, and I'm just going to multiply by negative 4/3 right away. That's going to get me x. And then over here, remember, we multiply numerator, so that would be a negative 20. And we multiply denominator to denominator, that would be 18. But this one can be simplified. Both of those can be divided by 2, which would get me negative 10/9 as your final answer. Okay, so that is how we solve one-step equations. Now, what else can we do with one-step equations? Well, sometimes we see them in a word problem or a story problem, however you want to phrase that. And we just need to know some key words sometimes. So when we look, some of the key words to know is sum, which means we are adding. It is the answer to an addition problem. Difference, which is the answer to a subtraction problem. Product tells me I am going to be multiplying, and quotient tells me I am going to divide. Okay, so let's kind of go through here and we'll highlight some different words and see if we can figure this out. So we start off on number 9. It says the difference between a number and 4, and I'm going to switch colors because this is a really important word right here, is 12. All right, so let's see if we can figure it out. Well, difference means subtraction. What is it going to be subtracting? A number. We're going to call that number X and 4. And then is typically is going to tell me that's my equal sign. So what does it look like? Well, X minus 4 equals 12. So now we go to solve it. We're going to add 4 to both sides. So X is equal to 16. Okay, let's try the second one here. Once again, I'm going to get the highlighter first, and let's see if we can get some words. We have product of a number and 5, and once again, we have that word again, is 45. Okay, so let's see if we can set this up. Product means multiply, so I'm going to take 5 times X, and that equals negative 45. Now notice I switched the order there. We like when we multiply a number to a variable. Remember, we call that number a coefficient. When we multiply that number to a variable, we like to write that coefficient in front. So now to solve it, we're going to take and we're going to divide by 5, and that would get me an answer of X equals negative 9. All right, so those are some number sentence words or word sentences. What if we did kind of more of a story problem with this? So we're going to start in, it says, Jermaine has $25 to spend. That's kind of important. So let's highlight how much he has to spend, okay, at a county fair on rides. Then if each ride costs $2.50, and the question is, how many rides can he go on? Okay, so if I go on one ride, what's it going to cost me? Well, $2.50. If I go on 2, it costs me $5. How am I getting that? Well, hopefully you understand that we're using multiplication. We're taking $2.50 multiplied by X, whatever that is, and that would tell me is equal to how much I can spend, which is 25. At that point, I'm going to take and I'm going to divide by 250. And then at that point, I'm going to sit there and I'm going to say, okay, how many rides then can they go on? So I'm going to divide that out. So we're just simply going to take 25 divided by 2.5, and we end up with 10. So on story problems like this, I always like to write a quick little sentence. So what I always like to write is, Jermaine can ride on 10 rides. And that way I know for sure, if I kind of read back through the question, I know for sure that I can answer, or I answered what the question was asking for. And that is how we solve one-step equations.